Swayam Prabha. Digital India. Educated India.
So, welcome back. We are going through the properties and their applications of Fourier transform. So, let us go through some more properties of this. The next one is Fourier transform of f of minus x equals Fourier transform, that is capital F of minus alpha, and Fourier transform of f of minus x bar is equals to f of alpha bar. Let us see the proof of the first one, then we will go to the second one, that is the Fourier transform of f of minus x. This is equals 1 by root 2 pi minus infinity to infinity f of minus x into e power I alpha x into dx. Now, this x I cannot keep it minus x. So, we are assuming, say, put y equals minus x in this equation. So, 1 by root 2 pi, the limit of the integration as x approaches infinity, y will approach then infinity, and as x approaches plus infinity, then y will approach minus infinity. So, the limit will be from infinity to minus infinity, since y equals minus x. So, it will be f of y into e power minus I alpha y, since x equals minus y, into minus dy will come. So, once I am getting this, this is nothing but 1 by root 2 pi minus infinity to infinity f y, this minus we are changing. So, I am making it minus infinity to infinity e power I into minus alpha, I can write down into y dy. So, therefore, this is again the Fourier transform of function where x equals minus alpha. So, this equals I can write down f of minus alpha, because here it is minus alpha is there, and from definition this is Fourier transform of minus x. So, that I can write down capital F of minus alpha. Similarly, for the second one, Fourier transform of f of minus x bar, this is equals, you can write down 1 by root 2 pi minus infinity to infinity. I am just skipping, I am making it in terms of y directly, and e power minus I alpha y into dy. I have skipped the earlier lines, because just before this slide we have shown that part, and this is equals 1 by root 2 pi minus infinity to infinity f y, this I can write it I alpha y dy, and this is nothing but I can put whole bar. So, that this is nothing but again Fourier transform of alpha bar. So, this I am writing this e power minus I alpha y as e power I alpha y, and I am putting the bar on both sides, because the properties will remain unchanged by this way, and this is nothing but the Fourier transform of f x whole bar. So, this completes the proof of the theorem. So, these were the two proofs which I had to do. Fourier transform of f of minus x equals capital F of minus alpha, and Fourier transform of f of minus x bar equals capital F of alpha bar. For the first part, I am starting, since Fourier transform of f of minus x is there, I am starting Fourier transform of f of minus x equals from the definition inside the integral f of minus x e power I alpha x dx. Substitute y equals minus x, so that your limit now will be changing to infinity to minus infinity, f of y e power minus I alpha y into minus dy, which again this minus sign I can limits I can interchange. So, that I can write it 1 by root 2 pi minus infinity to infinity f y into e power I into minus alpha into y dy, and which is nothing but f of minus alpha. So, this completes the proof of the first part. Similarly, for the second part, Fourier transform of f of minus x bar, directly I can write down 1 by root 2 pi minus infinity to infinity f y bar e power minus I alpha y into dy. And this, the bar I can put it on the entire integration, so that e power minus I alpha y can be written as e power I alpha y bar, and this integral is nothing but capital F alpha and bar will be there, and this completes the proof of the second part also. Now, the next theorem is Fourier transform of f x bar equals f of minus alpha bar. Please note this thing. If you see the earlier theorem, that is your f of minus x is f of minus alpha, and f of minus x bar equals capital F of alpha bar. Whereas, for this one, the f of Fourier transform of f x bar equals f of capital F of minus alpha bar. To prove this one, again I am starting with f of minus alpha. This is, I can write down 1 by root 2 pi from inverse transform f x into e power I into minus alpha x into dx. So that f of minus alpha bar, this equals, you can write down 1 by root 2 pi minus infinity to infinity, bar will come on f x, and this e power minus I alpha x will become e power I alpha x into dx. And since bar is coming, so e power minus I alpha x will be transformed to e power minus e power plus I alpha x, and this is nothing but Fourier transform of f x bar. This is Fourier transform of f x bar. So that this completes the proof that f of Fourier transform of f x bar is equals to f of minus alpha bar. So, let us see here. F alpha, f of minus alpha, I am starting with this one. This I know. From here, f of minus alpha bar I am writing. So that inside the integral f x bar will come, and e power minus I alpha will be changed to e power plus I alpha x dx, and the right hand side is nothing but Fourier transform of f x bar, which completes the proof of this particular theorem. Let us see some example. We want to evaluate the value of this Fourier cosine transform of cos of x square by 2 minus pi by 8. Again, please note that whenever I will try to solve this particular problem, I can do it directly. That is root over 2 by pi 0 to infinity cos of x square by 2 minus pi by 8 into cos alpha x into dx. But instead of that, let us do it in the some other way, where we will use various properties, and we will try to find out the Fourier cosine transform of this cos function cos of x square by 2 minus pi by 8. If you recall, we know this thing. Already we have done this. Cos of Fourier transform of cos of x square by 2 equals 1 by root 2 cos of alpha square by 2 plus sine of alpha square by 2. In previous lectures, we have already proved in one example, and similarly we know Fourier transform of sine of x square by 2 equals 1 by root 2 cos of alpha square by 2 minus sine of alpha square by 2. These two results are already known to us. We have done it earlier, that Fourier transform of cos of x square by 2 is 1 by root 2 cos of alpha square by 2 plus sine of alpha square by 2, and Fourier transform of sine of x square by 2 equals 1 by root 2 cos of alpha square by 2 minus sine of alpha square by 2. Now, let us start with the left hand side, that is Fourier cosine transform of cos of x square by 2 minus pi by 8. Let us start from here. This equals, can we write down this thing? Fourier transform of cos of x square by 2 minus pi by 8. Can we write down this? That Fourier cosine transform of this cos of this equals Fourier transform of this one. Again, if you recall, in one of the lecture we have proved that the Fourier transform and the Fourier cosine transform of any function is same. Since the Fourier cosine transform and Fourier transform of any function is same, therefore, you can write down Fourier cosine transform of cos of x square by 2 minus pi by 8 equals Fourier transform of cos of x square by 2 minus pi by 8. So, please note this one, since the Fourier transform and the Fourier cosine transform of a function is same, from using that property we can write down this. And once we are getting this cos term we can break it, cos of x square by 2 into cos of pi by 8 plus sin of x square by 2 into sin pi by 8 we can write down. So, that this pi by 8 I can bring it outside. So, cos pi by 8 into x square by 2. So, 1 by root 2 into cos of alpha square by 2 plus cos of plus sin of alpha square by 2 I can write down. Fourier transform of cos of x square by 2 I am writing it, already we have done it, 1 by root 2 this. Similarly, plus sin pi by 8 into 1 by root 2 into cos of alpha square by 2 minus sin of alpha square by 2. This again I am writing it as this one, Fourier transform of sin of x square by 2, which we evaluated earlier, that value we are substituting. So, that from here I can write down Fourier cosine transform of cos of x square by 2 minus pi by 8. This is equals to 1 by root 2 into cos of alpha square by 2 into cos of pi by 8 plus sin of alpha square by 2 into cos of pi by 8 plus I will obtain cos of alpha square by 2 into sin pi by 8 minus sin of alpha square by 2 into sin pi by 8. So, this equals, using trigonometric properties, I can write it simply cos of alpha square by 2 plus pi by 8, and the other term I can write down plus sin of alpha square by 2 plus pi by 8. Keeping the terms together, this expression first line I can write it in the form of cos of alpha square by 2 plus pi by 8 plus sin of alpha square by 2 plus pi by 8. So, that again this I can write down cos pi by 4 cos of alpha square by 2 plus pi by 8 plus this 1 by root 2, again I can write it as sin pi by 4 into sin of alpha square by 2 plus pi by 8 I can write down. So, 1 by root 2 in one place I am replacing by cos pi by 4, and in other place I can write it as this. So, basically cos A cos B plus sin A sin B format. So, this equals cos of pi by 4 minus alpha square by 2 minus alpha square by 8 I am getting, and if I simplify it, then I can write down cos of pi by 4 is there, sorry, this will be, this term is not correct, pi by 4 minus alpha square by 2 minus pi by 8 will come. So, that pi by 4 minus pi by 8 I will get cos of pi by 8 minus alpha square by 2, cos of minus theta is cos theta. So, that I can write this thing as cos of alpha square by 2 minus pi square cos of alpha square by 2 minus I pi by 8. So, therefore, Fourier cosine transform of cos of x square by 2 minus pi by 8, this equals cos of alpha square by 2 minus pi by 8, or in other sense the function is self reciprocal, because the Fourier cosine self reciprocal with respect to Fourier cosine transform, because Fourier cosine transform of the function is the function itself. So, it is your self reciprocal. Let us see here. So, again you see I am just using certain transform, some functions whose transforms are known to me, like Fourier transform of cos of x square by 2 and Fourier transform of sin of x square by 2 are known to us. Already we have done it earlier. So, using these two, now I am starting from Fourier cosine transform of this equals Fourier cosine transform of cos of x square by 2 minus pi by 8 equals Fourier transform of cos of x square by 2 minus pi by 8, because as I have told you earlier, the Fourier transform and Fourier cosine transform of a function are same, and we have proved it earlier. Using that property we are writing it. Now, this equals this cos function I am breaking into cos A cos B plus sin A sin B form. Cos pi by 8 I am bringing it down, and I am writing Fourier transform of cos of x square by 2 value, which we written in the earlier side. Here also for the second term sin square x by 2 sin pi by 8 into the Fourier transform of sin square x by 2 I am writing. Now, just I am using the trigonometric properties. Using the trigonometric properties, this I am writing cos this particular form, and here again I am write 1 by root 2 I am replacing in one place by cos pi by 4, in another place by sin pi by 4. So, that cos A cos B plus sin A sin B form can come, and ultimately I am getting cos of pi by 4 minus alpha square by 2 minus 8. This I can write down pi by 2 minus alpha square by 2, and this is again cos of alpha square by 2 minus pi by 8, since cos of minus theta equals cos theta. Therefore, Fourier cosine transform of the function is the function itself, and the function we call it as reciprocal with respect to Fourier cosine transform. Please note that with respect to Fourier cosine transform, not sine transform or like that. Now, let us solve this same problem using some other approach, so that you can understand one problem can be solved in various ways, and what is the advantage of using the properties of the transform to find out the Fourier series of some function. So, the same problem we are solving it now in the other approach. Your problem is you have to find out Fourier cosine transform of cos of x square by 2 minus pi by 8. So, as I told you, directly we can evaluate it using the fundamental definition of Fourier cosine transform. So, 0 to infinity cos of x square by 2 minus pi by 8 into cos of alpha x dx. So, this equals, I can write it as, this is 0 to infinity, this cos function is there. So, therefore, the function is a even function. So, since it is even function, so I can write down, I can break it, I can bring 1/2 here, so that this limit of integration I can change it from 0 to infinity to minus infinity to infinity, and for that reason minus half is coming outside, and this is possible only because the function is an even function. So, therefore, this equals cos of x square by 2 minus pi by 8 into cos of alpha x dx. So, therefore, since the function inside is an even function, so I am changing the limit from minus 0 to infinity to minus infinity to infinity, and this will not be minus, plus sign will be there, and this equals, again I can write down 1 by 4 into root over 2 by pi is there, minus infinity to infinity 2 cos of x square by 2 minus pi by 8. into cos of alpha x dx. Just I am multiplying by 2 and I am differentiating by I am dividing by 2. So, that half has become 1 by 4. So, that now it is in the form of 2 cos a cos b and I can break it into 2 parts. So, this is equals 1 by 4 root over 2 by pi minus infinity to infinity using the trigonometric formula. This you can write down cos of x square by 2 minus pi by 8 plus alpha x plus cos of x square by 2 minus pi by 8 minus alpha x will come here into dx. So, that this equals, now I can break it into 2 separate integrals. 2 separate integrals means I want to say 1 by 4 root over 2 pi minus infinity to infinity cos of x square by 2 minus pi by 8 plus alpha x dx. This is one integral. Other integral similarly 1 by 4 root over 2 by pi minus infinity to infinity cos of x square by 2 minus pi by 8 and this is minus alpha x into dx. So, that why I am breaking it into 2 integrals, because if you see the second integral, in the second integral if you put x equals say minus z, then I will get back it will be the same as first integral. Please check this thing, that in the second integral if I substitute x equals minus z say, then I will get back the first integral, or in other sense 2 integrals can be combined into a single integral. So, I am substituting x equals minus z over here, and once I am substituting x equals minus z over here, the second integral will become the first integral. So, that you can write down Fourier cosine transform of cos of x square by 2 minus pi by 8. This is equals to 2 will become, since it is same. So, 1 by 4 will be replaced, half into root over 2 by pi minus infinity to infinity cos of x square by 2 plus alpha x minus pi by 8 into dx. So, now this integral, because the second and first integral will be same whenever I will substitute x equals minus z say. This equals, you can write down half into root over 2 by pi minus infinity to infinity. This I can write it in whole square form, that is cos of x by root 2 plus alpha by root 2 whole square. So, once I am writing this, so I have to adjust it. So, after adjustment, cos of this will become minus alpha square by 2, this whole square term will not be there, and pi by 8 term is not here. So, this will be plus pi by 8 into dx. So, cos of x square minus a square form. So, this equals half into root over 2 by pi minus infinity to infinity cos of, now this I am writing x plus alpha by root 2 whole square minus alpha square by 2 plus pi by 8 into dx. So, therefore, on this what you are doing now, suppose I am assuming x plus alpha by root 2 equals v. I am substituting, you put now on this integral x plus alpha, sorry, not correct, this one, you put x this term. So, x plus alpha by root 2, this is equals to v. So, if you substitute on this, what you will obtain? Fourier cosine transform of cos of x square by 2 minus pi by 8. This is equals to, by substitution, 1 by root 2 minus infinity to infinity cos of v square minus this term will remain same, that is alpha square by 2 plus pi by 8 into dv. So, again I am writing just your substitution is x plus alpha by root 2 equals v in the earlier integral. So, once I obtain this equals, you can write down 1 by root 2 minus infinity to infinity cos of v square into cos of alpha square by 2 plus pi by 8 into dv plus 1 by root pi minus infinity to infinity sin of v square into sin of alpha square by 2 plus pi by 8 into dv. Basically, cos of a minus b, here it was cos of a minus b form I am doing it, and from there using trigonometric formula I am getting it. So, that you can bring this cos of alpha square by 2 plus pi by 8 outside here, you can bring it outside. So, this will be 1 by root pi cos of alpha square by 2 plus pi by 8 into minus infinity to infinity cos of v square dv plus 1 by root pi into sin of alpha square by 2 plus pi by 8 into minus infinity to infinity sin of v square into dv. Now, I have to find out the value of minus infinity to infinity cos of v square and also minus infinity to infinity sin of v square. This 1 by root pi into cos of alpha square by 2 plus pi by 8, these are the constant terms. So, let us see how to find out the value of this integral and this integral now. So, for this one minus infinity to infinity e power, I am starting with e power minus I v square dv. Since it is even, so I can write it as 0 to infinity e power minus I v square dv. If I substitute v square equals z here, so that it will be transformed into 2 into 0 to infinity e power minus I z into v square. So, z to the power minus half will come into dz. Now, here you put again I z equals t. Once I am putting I z equals t, so it will be 1 by I to the power half, z equals t by I. So, I to the power half will come outside, I to the power half 0 to infinity will be there, it will be e power minus t into t to the power half into dt, t to the power half into dt, which again if you wish you can write down 0 to infinity e power minus t into t to the power half minus 1 into dt. Now, I think it is a known function to you, that is gamma function e power minus t to the power n minus 1 into half gamma n. So, that you can write down this is equals 1 by I to the power half into gamma half, and gamma half is nothing but your. So, therefore, what you are getting here, that is 1 by I to the power half into gamma half. The value of this is minus infinity to infinity. So, again if I write down minus infinity to infinity e power I naught I v square dv equals root over pi, and this I to the power half, this I can write down cos pi by 2 plus I sin pi by 2 to the power half. I to the power half I can write it like this, and once I am writing this is equals, you can write down root pi by 1 by root 2 will come into 1 plus I, and this again you can write down, if you simplify this will be root pi into 1 minus I by 2 by root 2. So, that this will become root over pi by 2 into 1 minus I. So, effectively what you are getting? You are getting the value as root pi by 2 minus I into root pi by 2. So, therefore, from here you can e power minus I v square, which again you can write it in the form of cos and sin form, that is cos v square plus I sin v square. So, from here you can tell that minus infinity to infinity cos of v square dv, this is equals to minus infinity to infinity sin of v square dv, and if I equate the real part imaginary part, for both case I will obtain the same value, that is root over pi by 2. So, this I am writing in the e power minus I v square, I am writing in terms of cos of v square and sin of v square, and equating the real and imaginary part, I am getting the value of this. Therefore, Fourier cosine transform of cos of x square by 2 minus pi by 8, this is equals to, I got earlier 1 by root pi into cos of pi square by alpha square by 2 plus pi by 8 into root pi by 2 will come, plus 1 by root pi into sin of alpha square by 2 plus pi by 8 into value of the given integral is nothing but root pi by 2. So, once I am putting this value, substituting the value of these integrals, I am getting this. So, from here you can write down Fourier cosine transform of cos of x square by 2 minus pi by 8, this is equals 1 by root 2 cos of alpha square by 2 plus pi by 8 plus 1 by root 2 into sin of alpha square by 2 plus pi by 8. And this I can write it again in terms of trigonometry cos A cos B form. So, cos of pi by 4 minus alpha square by 2 minus alpha minus pi by 8, and which is nothing but cos of pi by 8 minus alpha square by 2, and using cos of minus theta equals cos theta, this again I can write down cos of alpha square by 2 minus pi by 8. So, I obtain that Fourier cosine transform of cos of x square by 2 minus pi by 8, this is equals to the function itself, which is the self reciprocal. I did the problem purposefully because I wanted to show you one thing, that if I do it directly using the integration, how much time it takes, how much effort I have to give, and how many difficult integrations I have to evaluate. Whereas, if I use the properties and if I use the Fourier transform of known functions, very easily I can find out the Fourier transform or Fourier cosine transform of complex functions. So, these are the usefulness of using the properties of the Fourier transform to evaluate the Fourier transform of a function. Thank you.